Hey everyone. Okay, so I'm assuming I'm streaming live, and I should just get started and go ahead. Cool. I'll take that as a yes, and I'll just start sharing my screen here. Okay. Cool. Awesome. So thank you everyone for joining. My name is Alejandro. My friends call me Alejo. People don't know, but I'm a dog on the internet. So if you see me as Satoshi Nakamoto, my pseudonym, no longer so pseudo, you'll feel free. I work at Pontem. We're building several applications on Aptos. We've been around for a bit. We started building with the Move virtual machine back in 2019 when Libra and Diem were a thing. And I'll go into a little bit of history there of that technology. It's a really interesting history, so we'll definitely dive into that. But before we go in there, I want to showcase a little bit of what we built, and then give you all a look under the hood of how it's being built with Move, get you all started with some of the products that we have for developers, specifically if you want to start coding right away with little to no code changes on local environments. You can start doing this right away with our Move Code Playground, very similar to Remix IDE. Everything deploys on the browser, and you can start coding without having to set up a local environment. So it's pretty cool. And yeah, just to give you a little bit of background on what we're doing. So we have the Move virtual machine that we made compatible with Wasm. Now Wasm is becoming a standard for runtimes across the blockchain ecosystem. Polkadot, Cosmos use it. Arbitrum in the near future as well will enable a custom runtime. So what we want to enable is essentially the same user experience that people have for deploying Solidity or EVM code across Ethereum, across BNB chain, across Avalanche, across Polkadot. In that same vein, we want to enable that for the Move VM. So as a Move developer, you'll be able to deploy your Move code on any layer one that will be compatible when we deploy the Move VM there. And why do you ask yourself? You probably ask yourself this question: why do I want to build with Move as opposed to Solidity? And I would say it's the same reason you probably want to build your banking infrastructure with something like C or Rust as opposed to Node.js. There's just certain languages like Rust which are safer in terms of certain features or functionality that are not enabled standard, which makes it harder to do certain things that are bad for the system. So one very specific example or difference between Solidity and Move is that reentrancy errors are not as common or are not possible with Move, whereas in Solidity, you really have to be careful as to which line you place certain libraries or you place certain codes. The most prevalent example is the DAO hack that happened that caused the Ethereum split into Ethereum Classic and ETH. That is still something that happens today. So we still see hacks happening with reentrancy errors, and obviously those are very bad. And the question then becomes: do we get comfortable with those types of hacks, or do we change to is there a paradigm shift where we change to something that's safer inherently? Now, don't get me wrong, you can still shoot yourself in the foot. You can still make mistakes. You should still get audited when you're building with Move. But a lot of these kind of like silly mistakes are not as simple or don't happen with Move. So this really allows you as a developer to just move a lot more quickly, a lot more confidently as you're doing code reviews. Also, not have to worry about so much about where specifically your code is going. Move inherently also has a checker that makes sure that essentially all the business logic that you're implementing works along with Move. So one key feature of Move, for example, is that native resources or how these are coded as coins or tokens cannot be inherently duplicated or discarded. So if you accidentally duplicate or discard a token, the VM itself won't let you execute that. So these are some of the features or functionalities of Move that just makes it purpose-built for blockchain, but still inheriting a lot of the security and efficiencies of Rust, because Move is essentially a framework or guide rails for building blockchain applications on top of Rust. And Rust is one of the fastest growing languages. A lot of people really like it. And yeah, we think this is also why people really like Move. Imagine if Solidity and Rust merged, and now you have this like easy to understand TypeScript-like framework on top of Rust that puts guide rails on the tokens, the smart contracts, so you're not shooting yourself in the foot as you're building this complex business logic. At Pontem, we're building several applications. So I mentioned the Move VM as one of our core products. We're also building a constant function market maker that supports both correlated and uncorrelated asset swaps. And we're also building a wallet. So before I dive deeper into this presentation, I just want to quickly show you what this application can do. It'll look very familiar. The coolest part is just how fast it's happening, given that it's deployed on Aptos. So that's, I would say, the coolest part or biggest benefit about Aptos is that throughput and that reliability, which will come once they launch. So here, for example, I want to send deposit one Aptos token and withdraw this amount of Bitcoin. So this is, you're all very familiar with the swap functionality. Here, it will pop up our wallet. And then once you see what the arguments are into the transaction, you can confirm it. And the coolest part is just how fast it happened. So if you're on Ethereum, you'd be waiting at least 14 seconds of latency for this to go through. You would also likely have to pay a lot in transaction fees. So if this was a small amount, then it would cost you a lot in those fees to trade. And yeah, you can do essentially anything you could do on some of the other exchanges or decentralized exchanges. You can add liquidity to different pools. We also have here functionality for you to swap stable assets, what we're calling a stable swap. So you can swap USDT for USDC. So you're getting both the functionality of correlated, uncorrelated assets, as I mentioned. You can add liquidity to pools. You can create your own pools and create your own markets. You can redeem your liquidity pool tokens and get your liquidity back. And then we're also indexing the blockchain to showcase the amount of users. And we have 156,000 unique addresses that are swapping or interacting with our contracts, which we think is really bullish for the overall ecosystem in Aptos. So yeah, if you want to learn more, go to liquidswap.com. We also have a homepage, home.liquidswap.com. We think this is an improvement over Uniswap, where you go to uniswap.org and it takes you to a landing page. Here you go directly to the app when you go to liquidswap.com. And yeah, let us know your thoughts and what you think about this. And yeah, now I'm going to demo some of the Move tooling that made this application possible. So I can't share, I'm not sure if I can share here to any chat, so I'll just say out the URLs, and if you can see them, then please follow them. So if you want, you can go on our website, pontem.network. And here you'll be able to access our documentation. And we have several tools that enable you to start building with Move that are going to be super useful for you. So the first one I would recommend is the IntelliJ IDE extension. So this allows you to do unit tests inside the code editor. It has the highlights for syntax. It has suggestions so that as you're starting out with Move, I would say this is probably going to be your best friend. We also have this in the Move code playground, which I'll dive into in a little bit, which is essentially a browser code editor that allows you to deploy and test code within the browser itself. So I'll run into this in a second. But if you're doing some serious development, definitely check out the IntelliJ Move IDE. You'll essentially just download the IDE, and then you can download the plugin. Just Google or look up Move language plugin once you get into and download the IDE extension. And it works with any of the IntelliJ platform tools. I recommend either PyCharm or CLion. If you're building with Rust, definitely use CLion. If you're doing like indexing or you're setting up some data tooling, if you're using Python a lot, PyCharm is a good one. And yeah, I can do a quick demo of that right now too, so you can take a look at what it looks like. But essentially, we're here, and let's say you want to start a new project, you want to launch a new project here. With this extension here in Move, you can essentially make sure that it gets pre-populated with the right folders. You also want to add a link to the Aptos CLI. So this actually, I'll go back. First thing you want to do is download the Aptos command line interface, which is going to be all the tools that you're going to need to build with Aptos. You can access that here from our documentation. Essentially download the latest version of the Aptos CLI. Their documentation is here. I recommend, if you're using Mac, just to install it directly in the binary folder. It takes a little bit, so I won't go into too much detail on how to do it. But this allows you to have several functionality. So, for example, as you're doing governance on Aptos, as you are deploying or testing your move code, there's also staking. Yeah, there's also stake tooling and tooling for operating your node. So if you're looking to dive deep into Aptos, this is definitely the first place to go. This command line interface tooling will give you everything you need. And then what will happen is you're going to install this and your user, hold on, let me share my screen real quick. You're going to set this up in your user, local user files. So let me just pull this up and I'll show you. Okay, let me share my screen again. Okay. So this will be set up in a binary folder in your local user files. So when we go here in PyCharm, you're going to install, first thing you're going to do is install the Aptos CLI. You're going to do that in your binary files. If you're using a Mac, it's a little bit more complicated, especially if you have the M1 chip. So just follow some instructions there. Just they're available online in our documentation as well. Once you install it, you're likely to going to install it in this location, users/local/binary or bin/Aptos. Make sure you have the latest version. If you do initialize and you have your own private key, so if you have your own private key already and you want to connect to a faucet or the REST API that you're connecting into, you can do that initially through here. So this is part of the IDE plugin that we built. You're able to get started right away from the IDE, which is awesome. You don't have to do a lot of the command line interface tooling. Going back here to the IDE, you could create. Now you have a new project. You can check your TOML file, make sure that is there, and sources. Okay, so now we're here. And now let's say you want to start a new Aptos project. So with the Aptos CLI tooling, I can just type in Aptos. You can see all the commands, help, version, what you can do in accounts. And then the first thing you want to do when you're starting a new project is essentially to call init. This is going to start essentially create all the directory that you need and kind of like pre-populate and walk you through the setup. So Aptos init. So it's asking me for a REST endpoint, just click connect, it'll do the standard one, which is the full node that Aptos maintains. If you want to set up your own faucet, if not, just use the one that Aptos maintains. And then, then you're going to be giving a private key, a public key. Obviously I'm screen sharing this, so I wouldn't use this. But now you have a public private key for your account. Now, when you're deploying contracts, you're going to want to make sure that you're using this key when you deploy your contracts. Actually, I can save this right now. Yep, so you create it and you fund it with the amount of coins. And now that this account is set up, I can now deploy modules. Modules are the equivalent of smart contracts removed here in this account. Oops, did not mean to click that. This will now be here in the config file. So you can also find your publicly, your private key, your accounts, the URLs you're using for the faucet and the API. You can then get started building here in your local environment. You can then deploy to Aptos through this REST API that is deploying to the DevNet, but now there's a testnet now available and pretty soon mainnet. So cool. If you're looking to deploy an Aptos to get started, definitely get started here. I'll also point you to documentation. In our documentation, there's an Aptos specific tutorial. So definitely recommend going through this. If it's your first time building on Aptos, if you've built on Ethereum, you'll probably be familiar with a lot of the tooling in the Aptos CLI that should be somewhat similar to like a truffle or a hard hat. And yeah, go through this. It'll walk you through some of the standard things you need to do. If you need help with understanding some of the concepts, what I would recommend as well is the Move book. The Move book, and I'll go into this in a minute, is accessible through our documentation. You can go here in the tutorials, and then within the Move playground, we link to it here. The Move book, I would really recommend. This is actually still stored in the Diem GitHub. And yeah, it's essentially just understanding the different paradigm changes between Solidity, Move, and how it uses or leverages Rust essentially as a standard framework for this. So definitely recommend going through this, reading the introduction. Some of the new terms you might want to look into is like generics. So these are the type parameters that you can create, resources, which I'm having trouble finding here in the but yeah, you can learn about resources, how they are native data types. I think they might be in generics. Anyway, resources, which are native data types, and enable, it's like one of the coolest parts about Move, which essentially means you can, implicitly duplicate or, get rid of a resource. A resource can be a token or a coin, which is essentially, how you transfer value. So this is one of those cool things about Move. And yeah, next thing I'll showcase is the Move playground. Essentially just showing you all how it works and how you can get started coding without having to set up a local environment. So, I had previously downloaded the Aptos CLI and just kind of showed you how you can initialize something really quickly. That might take you some time. If you just want to get started coding, go to playground.pontem.network. This will allow you to launch this browser code editor, which should be really useful for you to just get started, start learning. Recommend going through the tutorial that we have as well. So here in our documentation, under tutorials, you can also click here, Move Playground. And this is the tutorial that I'll walk through just to give you a taste of what the Move Playground can do, give you a sense of some of the features of Move, and hopefully get you started deploying and interacting with like the resources and some of the native primitives with Move that can get you started. If you're a Solidity or a blockchain developer, some of these will seem familiar, but a little bit different. But yeah, definitely recommend going through this because you don't have to set up a local environment. You can even do it from your phone if you want. So first, I'll just give you a quick overview of this interface. So you can export your code. So let's say you build something here, you can export it. It downloads into a zip file. Now the zip file you can just quickly put into your code IDE editor, use the Aptos CLI to further configure it or mess around with before you deploy it. That's super useful. You can also share it with a friend or share it with a coworker as you're building or iterating really quickly on the fly here in the code editor. You can also import. So if you have code here and you just want to put it on a device, don't want to have to manage the local environment setup, you can also import different files, and then they'll just come here in the Explorer. You can build. This one should work. Yep. So this built the project. You can do unit testing. You can clear the whole thing if you want. This should give you a tutorial, but I won't go through it. And definitely give us feedback as well on this as you try it out yourself. So here you can have several different projects. It comes preloaded with example projects so that you can take a look at some scripts. So scripts are how you can easily interact with different modules, the modules being kind of like smart contracts. And then within sources, you'll see the actual modules or smart contracts. So here's an example for an Aptos coin. So you as a sender are creating this module for Aptos coin. You use these dependencies. The dependencies can be linked here. So right now the dependencies are Aptos core, and the move framework, the standard library for Aptos, and the Aptos core framework. So you can add these dependencies here in the code editor, so you can use them in your code. You also want to add in addresses. So your address is sender. Keep in mind 0x1 isn't an actual address. You want to put in your actual address. So as an example here, you could put in this address and start testing stuff out, essentially in your code. I'm not going to change it because some of this stuff is coded to 0x1, but this is how you can add a dependency. And then when you export it, it'll work and you can deploy it on Aptos. Let's see what else. We give you some examples of different modules or contracts for Aptos, for a general coin, for storing information into addresses. So this one is part of the demo that we'll do today. And then there's some different unit tests as well that you can add on here to test whether your code is working or not. Let me go through this. The addresses, dependencies, okay. So first, what we're going to do is essentially based on the modules that are defined here, we're going to be interacting with some of these modules. So we'll show you how the different scripts interact with these. So essentially, when you're running scripts, when you run scripts here, the scripts are in your folder. So either get U28 or store U28, which is what we're going to do. You can run those here directly from the code editor, and that executes the scripts on the modules or smart contracts. So we'll go through that. So the first thing we want to do is just build it. Project was successfully built. Okay, check. If you get a failed, one, it'll pop up here. I guess we can do that here. So okay, so yeah, let's test what it might look like if this didn't build correctly. So let's go here in the scripts, get U28. Let's change this variable to be this, and then see what happens when we build this. So you'll notice you get a bunch of warning signs and also some error signs, and this will help you debug essentially. So if you scroll all the way down, you can see that we had an invalid name. Essentially this can be, the local variable can be named A. It has to be lowercase or start with this underscore. So we'll switch it back. Now that we build it again, it should compile correctly. Yep. So it's built. Cool. Okay, so now let's run some sample scripts. So okay, we're going to be running the get U128 and the store U128 functions. These both interact with the storage resource, which is defined locally in the storage module here. So we're going to be interacting with these two scripts to essentially store information into these addresses. So that's the demo that we'll do here. Okay, so first we're going to test it not working, so you can see what a unit test will look like. So here in the run scripts, I'm going to do get U128. And yep, so execution aborted with code 102 in module storage. So this tells me where I should go look at this, and based on the unit test that I'm doing, see what went wrong. So what does 102 say? It says that, let me do Control F. So here's, it should be here in storage. Okay, yeah. So 102 says that it checks if the resources exist in the address, otherwise through an error. So this address 0x5 that we ran the script in doesn't exist. So that's why this was wrong, or that's why this didn't work. If we were to do it with 0x1, it should work, or not. Oh no, because we haven't put this in the address. So this is what we're going to do next. So essentially saying that, yep, there's no address, there's no, it's looking in the storage module at address 0x1, and it sees that, the resource doesn't exist in this address, so it throws this error. Okay, so essentially what we're learning here is that the storage module is bound to the sender address 0x1, and not compatible with 0x5, which is one that we put in, we haven't yet defined. So nothing's being found at the address 0x5. So now what we want to do is store this value, or store value in 0x5. So this is what we're going to do. This is also done through a script. So let's say we want to store a value 1, 2, 3 in this address 0x5. This should hopefully work. Yep. So, gas used. Now what we did was change one resource under this address 0x5, and essentially added in 1, 2, 3 into it. And now you have a value is 128. So now we should be able to run this one, and hopefully that'll work. Yep. So then when we get U128, you see that it's there. And yeah, let's see. Yeah, you can do it. Also, you can store different values. But let's see what happens if we try to store. Oh, okay. So now let's showcase one of the key features of move, right? Which is that values can be implicitly duplicated or discarded. So let's say we wanted to, store now in this address a different value. We should get an aborted sign. Let's see. Store, execute the script will attempt to store. Okay, that didn't happen. So let me build this again and then run scripts. Cool. So now we say with code 101, this was aborted. So if we go back and see what's here with code 101 and what does it mean? So it says that it already exists. So since it already exists, I can't copy it. Therefore, I can't write another thing there. So this is a function of move. It's just showcasing that resources can be implicitly discarded or copied, which is good. You don't want your coins to be implicitly copied or discarded. But okay, how do we fix this? Essentially, what if we were to move that value from 0x5 somewhere else? So let's try this. Get U128 for 0x5. Run that in the scripts. Cool. So now what we did was essentially, we retrieved that value, which was 1, 2, 1, 2, 3. And now you can see that it's been reset as a value. So there isn't anything here. So you delete it. Yeah. So now it's deleted. Now that value 1, 2, 4, 5, 6 or 1, 2, 3 isn't there anymore. And yeah, that showcases Move's ability to not implicitly discard or copy resources. And yeah, so this should give you a good overview of getting started with Move. Definitely recommend you go through and check out the Aptos coin module. Some of the capabilities like burn or mint specifically. You can also run scripts for it if you want to mint some coins, some of the Aptos coins. Storage is good if you're looking to store values or store or do any form of more complex logic. Check out the different types of modules here that we have. Also more documentation in our documents. Definitely go through the Aptos tutorial as well as you're looking to do more complex logic on Aptos. That should be useful for you. And yeah, given that we have another 30 minutes or so, what might be cool is to kind of give y'all a background of how Diem and Move and Aptos evolved and how we got here. And hopefully that also motivates you to get started building. A lot of work went into this. We think it's a paradigm shift over Solidity for building business logic on blockchains. It really enables you to not shoot yourself in the foot with a lot of the design issues that Solidity has, unfortunately. So I'll just quickly go through this slide deck and then we can end the presentation. So yeah, just a quick history of Diem, how we got here. So Zuckerberg, call him here Satoshi, in 2017, essentially starts working on blockchain technology. So this was very, very early on. There's only a few employees at the time, Facebook, I guess it wasn't called Meta back then, that started working on blockchain technology and starting exploring the possibilities. This was 2017, as many of y'all know, was kind of like the hype of ICO. So I guess that's when Facebook seriously started looking at this. Then in 2019, the project Libra was announced as a fully permissionless cryptocurrency project. It was going to be a basket of essentially different currencies that was then going to be represented as a derivative currency that was a basket of these different currencies. And, it was going to run fully permissionless in a permissionless blockchain environment. And that was the kind of like genesis of Diem, Libra, the smart contract platform. The main use case of it was the stable coin that was going to be called Libra. That was essentially going to be a basket of goods across these different currencies. That same year in September, Libra itself faces regulatory hurdles, and some of the key stakeholders start to leave, unfortunately. When you're trying to disrupt the entire world with tech, it's definitely very hard to get through. But some of the regulatory concerns are definitely very valid. Like, you don't want too much like a central point of failure of one currency to take over the world, especially if that's a basket of goods of different currencies. You don't know whether those different currencies can be price manipulated. You don't know how the backing of those different currencies, whether the underlying governments can pay bonds and those won't get hyperinflated. So there's definitely a lot of questions around how this Libra coin or stable coin or currency was going to be maintained, which made it difficult to launch Libra. In 2020, they rebranded as Diem, and now they're doing essentially a permission blockchain. So there's a lot of concerns around the permissionless aspect of it. Any validator can join the network and, without having done KYC ML, essentially validate these transactions. Who knows if these could be malicious? If enough of them get together and collude and we don't know who they are, they could change the record or roll back transactions. That's definitely very dangerous. So I see why for a project this ambitious, a permission blockchain was a good idea to try to pursue. And then to make sure that there wasn't any concerns around outside dependencies of other currencies. Diem wanted to launch with a one-to-one backing of US dollar reserves. So very similar to like a USDC or a Tether. They wanted to form a digital derivative that has one-to-one backing with either cash or cash equivalent, like a short-term treasury bond. So that was the rebranding of Diem and how it came back to life. They still retain that vision of financial inclusion. Facebook and Meta as a distribution platform has access to over 3 billion people. So allowing these folks to get US grade investments or even currency is a huge leap forward. Imagine you're in a developing economy or developing country undergoing hyperinflation, like in Venezuela. If you could have access to a stable coin or a derivative of the US dollar, that could be huge, for how you store wealth, how you pass that wealth on, how you purchase goods. So that was truly revolutionary. And, hopefully we're still able to get there and allow billions of people around the world to adopt crypto. But Facebook was definitely going to be making good headways there. And now in 2021, that's when Pontem launched. We raised 4.5 million to essentially start building with the Move VM, and help projects find product market fit before deploying onto Diem. Now we've positioned our product to essentially enable the Move VM to exist in any layer one, but we're still super excited about this. And as we all know now, Diem was sold off to Silvergate for over $200 million in assets. And now 2 projects have spun out of the teams that were originally working on that, and that's Aptos and Sui. And we're working very closely with the Aptos team to essentially build applications and deploy those applications on the Aptos blockchain. As you saw earlier today, we have a constant function market maker and a wallet, which we'll be deploying. I'll quickly go through some of the other aspects of Diem that made it super interesting. So Diem was actually, even though it was a general purpose smart contract platform, it was built with a single application or purpose in mind, which was that stablecoin, that Libra or Diem stablecoin. And at least from the white paper that they had out, it was either going to be single currency or multi-currency. Single currency being specifically one-to-one backing, and then the multi-currency ones being a basket of different currencies, which enable pegging to essentially like index of these different currencies. And then those are backed with either cash or cash equivalents in order to maintain that peg. And yeah, this is going to be governed by an independent association, the Diem Association, which was going to be independent of Meta, and it was made up of several participants like A16Z, Coinbase, PayPal. I know Visa was there, and I think they backed out. Lyft, Uber, a bunch of really large entities that are part of the Diem Association, which was going to be completely independent and overseeing the system for payments. The Diem blockchain itself is super interesting. That permission architecture required vetting and KYC of validators and these virtual asset service providers, or VAS, essentially to enable the funds and the counterparties within the system to be fully compliant within these KYC requirements. They were also working on on-chain and off-chain protocols to enable privacy and compliance with regulations such as the travel rule, which means that you need to pass these KYC information between two compliant parties as transactions are going through, especially if they go above a certain threshold and the transaction size. It was using the Move language. That's one of the key innovations that came out of Diem and Libra. The architecture itself uses Byzantine fault tolerance. It's a derivative of hot stuff. So something that was, BFT consensus has been around for a really long time. But this hot stuff derivatives was implemented on Cosmos, if I'm not mistaken. And now the Diem or Aptos BFT is also a derivative of that. So it's tried and tested. So he also uses Merkle trees as opposed to linked lists for ledger history. This makes it a lot easier to access. I guess it also supports privacy. This is from their white paper. You also have gas, so that's important. The gas market and enable some of the issues that Solana has had with congestion, making sure that there's an efficient gas market there to prevent congestion. Some of the main benefits of the Move language, I think this is probably the coolest innovation that's stemmed out of Diem and Libra, is that you can essentially do this parallel execution and storage or sharding a lot more easily with Move. You also have these off-chain static verification tools like the Prover. Some of this stuff is also on Ethereum, but this comes natively with Move, which is cool. You have some of these built-in safety measures with the bytecode verifier. So for example, that the resources can't be duplicated or discarded implicitly. The Move flow is static. So it does this, first the code compiles, then it's checked, and then it passes all the checks, it's then executed. So this ensures that, exactly what you're expecting to execute gets executed and nothing else. So literally it has this dynamic dispatch. So the logic is determined at the runtime instead of when compiling. And this can lead to some of these reentrancy errors like the DAO hack. So this is one of the key features of Move that makes it safer than Solidity. It's also relatively easy to use. You can define compared to Rust proper. If you're building with Rust, at Solana, they call it eating glass. And it's because it's so difficult to build with Rust, but with Move, it's a way more seamless user experience. So yeah, you can define these custom resource or data types, which are the tokens or the coins. Coins are fungible tokens and tokens are non-fungible tokens. And these can be copied or implicitly discarded. That's what we saw in the Move Playground demo. They can only be moved between the storage locations. So that was when we moved, what was it, 0x5, and we deleted it or moved it away. So that was a very explicit action. That couldn't have happened implicitly, as you saw it through an abort error. this is built on Rust using the modules, resources, architecture, which is similar to class objects. It also uses capabilities, which is also kind of similar here. So definitely read up on the capabilities. That's useful for understanding how to use Move. You also have built-in access controls or permissions, which you need to code into Ethereum manually. And it's relatively blockchain agnostic. So this is why we want to deploy it on different layer ones. We think this is, purpose-built for blockchain, but agnostic to which L1 you deploy to. So that's what makes Move really nice. One of the key features of Move, which enable this, is this atomic resource type. So these are used to create these digital assets that have the programmability. So these are other coins or tokens in Aptos, but they can, they can kind of expand beyond that. And these are ordinary values that can be stored as data structures. They can be passed in as arguments or into functions. And then they also return procedures. And these are defined similarly to objects in other languages. The cool part is that they can be duplicated, reused, or discarded. So I'll keep saying that because it's one of the coolest parts about Move. This allows you to really not shoot yourself in the foot with how you handle tokens, so you don't accidentally delete them or mint a bunch of them, which also isn't good. Or reuse them, double spend them. That's also not good. So resources enably allow you through the bytecode verifier to not do this. You can only create them or destroyed by the module that defines it, and that's deployed with your address. And then this is guaranteed and enforced by the bytecode verifier. So going back to this, remember the Move flow is static. So first you compile the code, then the code is checked in the bytecode verifier. If it passes these checks, the atomic resource types aren't being discarded, reused, or copied, then it goes through and it executes. So that's one of the cool functions of Move and why it's so powerful for building smart contracts without you kind of accidentally shooting yourself in the foot. Diem also had, and this is going back to Diem also had this protocol level compliance, which, hasn't really been seen elsewhere. I'm not sure, if this is something that the permission change will go in the future, but I generally think this should probably go above or have a layer on top for compliance reasons. You probably want to have a neutral platform that's censorship resistant. But then essentially you had treasury authentications from treasury accounts and root accounts, which was controlled by the Diem Association to enable certain things, potentially also halt addresses, if they were non-compliant with sanctions, for example. And then you had accounts and access control across this. So it was going to be a permission chain, essentially to enable this regulatory compliance within the regimes that Meta operates, which would make it essentially, like a payment system that's decentralized, but there's still these central points of control which are in there for compliance reasons. For example, if the address is sanctioned by OFAC, then you want someone to have the ability to go in there and block that address from transacting or freeze their funds, essentially. So that was going to be possible in Diem. Some of the economics that went into it, again, the main use case of Diem was going to be Diem or Libra was going to be the stable coin. And the way they were positioning this in their white paper is going to be a complement, not a replacement for some of the domestic currencies. So it was going to be complementary to say something like a CBDC and not really replace them, since it was storing the actual money. Let's see. Essentially, what they wanted to do was aggregate a bunch of these different currencies and create like a basket of goods, which maintains a single stable coin that's a blended, based on nominal weight. So let's say you want, 50% US dollar, 18% euro, 11% the British pound, et cetera, et cetera. You can create then this basket of goods that then is a derivative coin of the different prices of these, which should be a hedge, or I guess a diversity against the different the free floating prices between these. So this is very similar to what the IMF has for different goods. In order to not have this be like money printing, right? These needed to be backed one by one with either cash or cash equivalents. So the way that the Diem reserve of coins or currencies was going to be made up was essentially 80% short-term government securities, so like treasury bonds, which should be as good as the cash equivalent in that country, and then 20% cash, essentially your cash equivalents, essentially enabling the system to freely deploy and absorb liquidity from these currencies. So in the case of a bank run, for whatever reason, 20% of it would be in cash, and then 80% of it would be short-term maturity government securities or bonds, so that they could be sold within a short enough period of time. They also had some systems, emergency stop systems in place in case there was a bank run. I would imagine there's, because the 80% is in the short-term government securities, that they're earning yields on these treasury bonds, and that can be protected against. Oh, they did have a buffer, a capital buffer. Yeah, so they did have extra cash there in case there is negative interest rates. So when you have negative interest rates, those short-term government securities are no longer giving you yield, and they're now at a cost. So they definitely had a capital buffer there in case that happened. In case there's operational risk. They would do public audits of the composition of these reserves and the fair market value of the assets. Given that 80% is in government bonds, they're earning a huge amount of interest. They're earning a lot of interest rate. Imagine like trillions of dollars put into this. That would go to maintain the servers, the validators, I would imagine, and ensure that there's very low transaction fees of the money flowing through here. They also had some emergency operations, just in case there was a run on the bank, to ensure that, people were safe and this thing didn't implode. These are some of the different entities in the network that enable this permission or compliance framework. So again, it would be kind of interesting to see if someone in the future tries to do this, because it generally does make sense, I guess, for protocol level compliance. But right now, I think we need to self-regulate and build this on top. But for example, you have the association, it conducts a lot of the due diligence on the parties or actors that are interacting here. They control the minting and the burning of the coins, and they monitor for suspicious activity. You also have the designated dealers, which are essentially exchanges or well-capitalized institutions, and these serve as intermediaries between the Diem Association, which is minting and burning coins, and these serve as intermediaries between the exchanges, and so they're not exchanges, sorry, between the Diem Association and the exchanges. Essentially, they're well-capitalized financial institutions, I imagine, maybe like banking partners. And they facilitate the liquidity of these coins for the end users through these exchanges or OTC dealers, probably while also custodying the currencies, I imagine, if they're the banks. Then you have the virtual asset service providers, or the VAS. If you keep up with like regulatory news, VAS is one of those key words. Essentially, if you're performing financial services or custodying coins, you should be a VAS in a lot of these jurisdictions. VATF is they're not a governing body, but they give recommendations to local jurisdictions. They define this term. And essentially, it's just a regulated entity that's subject to the due diligence and risk-based, the KYC ML. They should be undergoing certain aspects of compliance procedures to enable people to interact with virtual currencies. And then there's the unhosted wallet users. So these are just non-custody or self-custody solutions, essentially different addresses, different users in the network that should be able to transact with each other, but they're not associated with one of these virtual asset service providers. So these would be regular users. The association is running through and making compliance checks, checking for, making sure that there's no suspicious activity in the transactions, making sure they're doing the KYC ML check where required, or that the virtual asset service providers are doing it and passing on the information as appropriate. They set certain standards and frameworks for how people should use the protocol. And there'll also be some protocol level controls, essentially making sure that like sanctioned addresses and jurisdictions and are being blocked, I imagine, and that the virtual asset service providers are going through a rigorous certification process and abiding by things like the travel rule. And now that brings us to Aptos. Aptos is an iteration on top of Diem. I believe it's better. It's going back to the original spirit of what Libra was aiming to be, which was going to be a fully permissionless system. Aptos is not going to be solely purpose on building a stablecoin, which was Libra and Diem's purpose. It's going to be a general purpose smart contract platform. It's really cool that it's using a lot of the same tech and innovation that we saw come out of Libra and Diem. So not only the move language, but also the Byzantine fault tolerance consensus mechanism. They're also using pipeline execution for enabling this parallel transaction execution. They're using proof of stake, so they're a full proof of stake system. Ethereum just merged there. Let's see, make sure that's safe. Hopefully that goes well. But Aptos will be, going through and using best practices for proof of stake. You can do flexible key management, so you can rotate your keys, for example, relatively easily, and doing that natively. That's a cool feature of Aptos. They also have this pipeline and modular transaction processing, which enables the high throughput. It also enables new use cases, like batching together these transactions without them colliding. Econia is a good example of this. So check out econia.dev. If you want to see this in action, how a central limit order book can do this better than prior. The protocol itself also doesn't require upfront knowledge of the data that's going to be read or written. And this oftentimes in systems like Solana breaks the transaction atomicity, which can be an issue. So Aptos solves for this issue. And they also have this modular architecture, which optimizes for upgradability. So as it continuously improves, they can essentially do these upgrades and improvements to the Aptos blockchain as it's live, which, as we saw with Ethereum or Bitcoin, these types of upgrades are not really baked into the protocol, so are not really possible. And yeah, while we're here, there's a lot of challenges for people building on Aptos. So we're building different tools. As you saw, the IDE, the Move Playground for people to stop building. You definitely require different expertise, and we're here to help. And this liquidity infrastructure is also nascent, which is why we're building the constant function market maker and the wallet to enable people to transact liquidity through these open permissionless systems. So yeah, I believe that's it. And it looks like we're also running out of time, only 5 minutes left. So yeah, thank you all for the opportunity to be here. Really excited. You can find us on Twitter. You can find us on Telegram. You can find us on Discord. It's Pontem, P-O-N-T-E-M network. You can just search there. My name's Alejo. On Twitter, I am AliJ0x, so ALEJ0x. If you want to follow me, you can follow me there. Not as active, although I should be. Right now, it just sets down on building. But once I can pull my head up, I'll put out more thought leadership stuff. So yeah, thank you all for the time. I hope you enjoyed these demos. Please go use the products, start building with Move. If you have any questions, reach out to us on any of our channels. We're happy to help as much as we can. So yeah, thank you for the time.